3-5 scatter plots and trend lines. What we're going to be talking about today, we're going to create and interpret scatter plots. We're going to use trend lines to make predictions. When you have a scatter plot just is a graph that has points that are scattered all over the place. It's not a function where you can say, I put in 1 in for x, I get an actual answer. Is this big enough? The table shows the number of species added to the list of endangered and threatened species in the United States during the given years. We're going to graph a scatter plot using the given data. That's what you see here. In 1996, 91 new species were added. 97, 79, 98, 62, 99, 11, 2000, 39, 2001 is 10, and 2002 was 9. Now for my graph, I only have this piece. I don't have the full XY axis. Anyone know why I don't have the full piece? Guess. I can't have a negative number. Will I ever have a negative year? Can I have negative species put on the list? No. So I'm not going to have a negative. So I only need to put a big giant L in one of the quadrants of your paper. So in one of your quadrants of your graph paper, put an L. Now to graph this. On the bottom I have, or actually if this was a normal table, what value would this be? X's are on top, Y's are on the bottom. X's are usually time. So this is years. On the left is going to be your species. What would be a title for this graph? I would probably use that as my title. Usually your title can come right from the original example, original problem. The title of this is species added to the list of endangered and threatened species in the U.S. You can cut out a few of the words. I just took actually and copied and pasted. I know sometimes when you were taught this, you did this at the end. You did all your labeling at the very end. But what happens when you wait to the very end? You forget. Once you get done graphing, you say, okay, I'm done, and go to the next problem. You need to have labels. This way, anyone who picks up a graph actually knows what you're talking about. If you do all the labeling at the beginning, you're less likely to make a mistake and forget about it. Now I can worry about my scales. How many numbers do I have here? 1, 2, 3, 4, 5, 6, 7. I know I have 10 boxes here. You probably have a little bit more than 10. So you might want to go every one, every other one, whatever way you can get it to fit. But you don't want to change your scale. You don't want to go 2 spaces, then 1 space, then 2 spaces, and 1 space. You want to keep it the same. So I'm going to do 96, 97, 98, 99, 2000, 2001, 2002. Now for time, we usually just put whatever they give you, flat down. Don't change anything. But you can't do that on the left. I can't go 91, 79, 62, 11, 39, 10, 9. If you do that, your graph is incorrect. That is not how you graph. You need to look, what's your highest number? 91. That's my highest number. So I need to get up to 91. I know I have 10 spaces. I'm going to count by tens because I want to use as most of the paper as possible. Because if I counted by hundreds, what's going to happen to my graph? They're all going to be squeezed in right here. Are you going to notice anything about that graph? No, you're never going to tell, does the graph go up? Does it go down? You need to stretch it out. So you count how many squares you have and figure out what you need to do. So I'm going to count by tens. Now you don't have to label every single one. Notice all I did was put a 10. All I did was put a 10 on one line. That means every single line is 10. If you put 10, 20, 30, 40, 50, all the way up to 200, it's not going to change anything. But you need to put some sort of label to let me know the scale. Now we go to graph. In 96, how many species? 91. So 96 goes up 9 and just a hair. Now yours might be different if you didn't go by 10. The next one in 97 is 79. So I go up almost to 8. In 98 it is 1, 2, 3, 4, 5, 6, and a little bit. 99 is 11. So go up 10 and a hair. 2000's 39, which is almost 40. 1, 2, 3, 4, just below it. 2001 is exactly 10. 2002 is just below. Looking at the graph, what can you interpret? What could you tell me about the number of species being endangered? There's less. How can you tell? If you look at the graph, they are going down. There's a decrease in the number of animals that are added to the list. It doesn't mean that there's less species endangered. It means there's less being added to it. Notice how it's not a perfect straight line. It went down one year, it went up one year. Then it went back down, and it stayed down. We could probably look it up now. It's probably going to be up or down. It's probably not going to go perfect. Because if I went on the same exact trend is the pattern. It would be like if I took a line and drew it through here. That's pretty much the general pattern, right? What would it probably say then in about 2003, 2004? There's actually no species added. And then realistically, in 2010, it's saying, if it was negative, what's happening now? They're getting taken off, which it does happen, but it's not as likely. And there's your graph. What can you tell me about all of these? They're going down, right? Now our trends, I'm going to skip ahead just a little bit, are called our correlations. Correlations is just how the data sets are related. If it has a positive correlation, what do you think you can tell me about the dots? The dots are going up. They're increasing. There's a positive correlation. I just put X's on there. Negative, that's the one we just had. It's the one going down. There's one last one. The last one is no correlation. There's no relationship between the data sets. Looking at this one, yes, the no correlation and the negative correlation do look similar. But when you look at these dots in general, what's happening as I go on? They are going down slowly. Later on in Algebra 2, we'll talk about how spread apart and how close they are to a perfect line. It's strong or it's weak. It's weak if it's spread apart. This one's fairly weak. If I look at these dots, if I go from left to right, it goes up, goes down, up. It's all over the place. If I try to connect the dots, wait, was it up? Oh wait, they're both up. All three of these are here. So look where I started, look where I ended. They're about, yeah, it's all over the place. But if I look at this one, what's happening to my points? They're going down, slowly but surely. Here's another one. So in another quadrant, we're going to put another scatter plot. You can put the whole thing on that graph paper if you wanted. The table, the graph. This one's the duration of several eruptions of the geyser Old Faithful in the interval in between eruptions. Everyone knows what Old Faithful is. It's a geyser, shoots out water out of the ground, happens every so often. So water came out of the ground for a minute and a half, and then it took 50 minutes for the next one to happen. Next one happened for 2 minutes, and then it waited 57 minutes. It's not perfectly timed. So write down the chart. Now, the one thing I did fail to mention, when we're talking about time, what can you tell me about every single one of these? They're decimals, but if you look at them, they're not. It doesn't even matter that they're by fives. It matters that they're in order. Because we don't want to go 1.5 minutes, 2 minutes, 5 minutes, 2.5 minutes. You want to keep them in order. So if they're out of order, make them in order. On the bottom, I'm going to put my time. And this is my duration. And this is in minutes. On the left-hand side, I'm going to put time again. But this one here is the interval in minutes. Now for my graph, I just put the numbers as they were on the side, counted by one space. On the side, the highest number I have is 89. Well, I'm just going to count by tens because I have 10 lines there. At 1.5, it's 50. 10, 20, 30, 40, 50. At 2, it's 57. At 2.5, it's 65. At 3, it's 71. 3.5, 76. At 4, 82. 4.5, 89. what could you tell me about the correlation? It is a positive correlation. And the title, I would probably use duration of eruptions at Old Faithful. That's all you really need. Questions on scatter plots? All it is, it's graphing, and the plots are all scattered. That's why it's called a scatter plot. Now, you don't always have graphs to look at the correlation. Is there a relationship between the temperature in Houston and the number of cards sold in Boston? There's no relationship, right? No, it doesn't make sense that there's a relationship. How about the number of members in a family and the size of the family's grocery bill? Is that going to be a positive correlation or a negative correlation? Is it going to go up or is it going to go down? Up. It's going to go up, so it's a positive correlation. The more family members, the more the grocery bill is going to be. It's not the more people in your house, the less groceries you're going to buy. Technically, yeah. The number of times you sharpen your pencil and the length of your pencil. Is there a relationship? What's happening as you sharpen your pencil? So, is it a positive correlation or a negative correlation? Negative, because it goes down. How about how much TV you watch and how much homework you do? It's a negative, because the more TV you watch, the less homework you do.